Welcome to Study Loop.
Okay, so this is the free body diagram I drew for the first case. So we know the first case is that a block is moving to the left. So therefore, it should experience 4 different forces here, which is the normal force from the surface, gravity of itself, and the force P, and the FAB, which is the force from the link AB, okay, which is FAB here. As you can tell, FAB has an angle 35 degree. So if I decompose FAB, I have an XY component of FAB. So the X component of the FAB is FAB cosine 35 degree, which is pointing to the right. And the Y component of the FAB is FAB sine 35 degree, which is pointing downward. So therefore, if we apply Newton's second law, we have Fx, which is the net force along the x direction, is equal to 0, which is equal to FAB cosine 35 degree minus force P. So therefore, P is equal to FAB cosine 35 degree. And Fy, which is the net force along the y direction, is equal to 0, which is N minus G minus FAB sine 35 degree. So eventually have the normal force N is equal to G plus FAB sine 35 degree. And we know friction is equal to FAB cosine 35 degree. Okay. So we also know that friction can be equal to mu Kn. Okay, since in this case it should be a kinetic friction since the block is moving. So we have mu Kn is equal to FAB cosine 35 degree, which is mu Kg plus FAB sine 35 degree is equal to FAB cosine 35 degree. If we do some arrangement here, eventually have FAB is equal to mu Kg over cosine 35 degree minus mu K sine 35 degree. So therefore have force P is equal to FAB cosine 35 degree, which is mu Kg over cosine 35 degree minus mu K sine 35 degree, and then times cosine 35 degree. So we know mu K is 0.25. G, which is the gravity of the block, is mg, which is 10 kilogram times 9.8 meter per second square, and it's give us the gravity of the block is 98 Newton. So therefore, the force P should be equal to 0.25 times 98 Newton over 0.25 and then times it's cosine 35 degree minus mu K sine 35 degree. So it's cosine 35 degree minus 0.25 times sine 35 degree and then times cosine 35 degree. And this will give us the force P is equal to 29.7 Newton. And for the next question, so now the block is moving to the right. So the block should experience 4 different forces here, which is the gravity normal force and the force from link AB and the friction. And in this case, the kinetic friction is equal to the force P, okay, since it's moving toward the right. So if we know that FAB also should have an angle 35 degree here. If we decompose it, we'll have XY component of FAB. So the X component of FAB is FAB cosine 35 degree, which is pointing to the left. And the Y component of FAB is FAB sine 35 degree, which is pointing upward. So therefore, if we apply the Newton's second law, we'll have the net force along the X direction, which is equal to 0, which is equal to F minus FAB cosine 35 degree. And therefore have friction is equal to FAB cosine 35 degree. And on the y direction, the net force Fy is equal to 0, which is equal to G minus N plus FAB sine 35 degree. So therefore we have N, which is the normal force, is equal to gravity minus FAB sine 35 degree. And we know friction is equal to the kinetic friction, which is mu Kn, which is equal to mu K times G minus FAB sine 35 degree. So therefore, we have mu K G minus FAB sine 35 degree is equal to FAB cosine 35 degree. So if we do some arrangement here, eventually we have FAB is equal to mu K G over mu K sine 35 degree plus cosine 35 degree. So therefore, we have the friction is equal to FAB cosine 35 degree, which is mu Kg over mu K sine 35 degree plus cosine 35 degree, and then multiplied by cosine 35 degree. And when the mu k is 0.25 and the gravity is 98 Newton, so therefore we have the friction is equal to 0.25 times 98 Newton over 0.25 times sine 35 degree plus cosine 35 degree, and then times cosine 35 degree. And this will give us the friction is equal to 20.9 Newton, which means that force P should have the same magnitude as the friction, which is 20.9 Newton. And these are the answers for this question.